Greetings, this is Chemistry with Nav. In this video we're going to take a look at polymers, and for AS that's going to be addition polymers, so the process is known as addition polymerization. First of all, a polymer itself, what is it? Well, it's a long chain molecule made up of many monomers. And the monomer is a discrete molecule, meaning it's an individual molecule. And in this instance, for addition polymerization, it's going to be an alkene. And the reason why that works is that if you imagine you have your alkene and you have an alkene next to it. So the way that I describe this to my students is that if every student in the school stands in the corridor and they hold both their arms up in front of them, making an equal sign as if they are making a double bond in front of them, then all they actually have to do is switch that to their right hand side and they grab the person to the right of them. And if everybody grabs just the person to the right of them, then in fact you end up connecting all of the molecules together. So it would look like that. And you end up making one long chain of people. So that's actually what's happening here as well. So in this example we're going to use propene, because propene is often something that's done badly, for the reason that is the way that it's drawn. So I've drawn it out here with the carbons in a row, and a lot of students will try to polymerize through that whole carbon chain, but it's not. It's just that carbon-carbon double bond, as it was in that example. It's just that carbon-carbon double bond that actually does the work. So what I suggest is that you redraw your alkene, and you redraw it around the carbon-carbon double bond. You ignore the bond angles, and you put just the four groups around the carbon-carbon double bond. And that means here we're going to have CH3. Because once you've redrawn this, and you've redrawn it in the square style, it makes it much easier to work out what the product's going to be on the right hand side there. Because when you polymerize propene, you end up with a structure that we draw like this. It doesn't have the double bond in it. So that double bond is opened out, and that is called a repeat unit, because if we were to photocopy that bracket, say 100 times, and then cut it out, we could stick them together in a row and it would show us the structure of the polymer. The only thing we need to add is the number of molecules, and so in this case we would use n number of propene molecules, which would give us an n repeat of that bracket. So if you can redraw your alkene, that will show you the structure of what it is you're making quite clearly. And in terms of naming it, nice and easy, use the word poly, open the brackets, propene. And it retains its name because of the molecular formula. It's a repeat of still C3H6. Just moving on to a slightly different aspect of this, which is looking at the repeat unit, looking at the polymer chain and working out what the repeat unit would be. So if this was given to you in an exam, you might be asked to find the repeat unit from that polymer section, and then potentially work out what the original alkene was. So what you're looking for is some sort of repeating pattern, and the repeating pattern that we have here is in this HCH3, Now you could also say that the repeating pattern was here, but because you end up with two half repeats at the ends, then you have the same thing. So I'm going to stick with what I've done at the top there. Using that as the point to split up the polymer, that gives me the H, the CH3, the H and the H, and we keep those continuation bonds and we say that it goes n times, and in this particular instance n would equal 3 because there are 3 repeat units. So this is the polymer section, and this is called the repeat unit. And then from that repeat unit we can draw the original alkene, and drawing it in this way Again, ignoring the bond angles would still be correct for an exam. And that is your monomer. Now there are a few more things you need to know about polymers, such as the disposal of polymers, which includes burying them in landfill, sorting and reusing them, and also burning them for energy. Sustainability of polymers is something else. You can actually make polymers which are biodegradable and so forth. So do have a read around those topics as well.